There's a place in space where the laws of physics are broken, a place where time stops, gravity becomes infinite, and anything that enters can never escape, not even light. It's called a black hole, and these mysterious cosmic objects may be the key to unlocking the secrets of the universe. But first, what exactly is a black hole? Well, it all starts with a star. Stars are giant balls of gas that make their energy by fusing hydrogen into helium in their cores. This fusion reaction creates a tremendous amount of energy, which generates an outward pressure that balances the inward pull of gravity. But when a star runs out of hydrogen fuel, the balance is broken. Without the outward pressure from fusion, the star's own gravity causes it to collapse in on itself. And if the star is massive enough, this collapse continues until all of its mass is squeezed into an infinitely small point, known as a singularity. As the star collapses, anything that gets too close, including light, gets pulled in by the intense gravity and can never escape it. That's because the only thing that can escape a black hole is empty space. Everything else gets trapped forever. Once something crosses a black hole's event horizon, it's impossible to come back out. Not even light can escape. That's why black holes are black. They don't reflect or emit any light. We can only see them by observing the effects they have on other objects. And the good news is that black holes are not cosmic vacuum cleaners. They only affect things that get too close. For example, if you were near a black hole, but far enough away so that its gravity wasn't strong enough to pull you in, you wouldn't feel anything unusual. You could even pass by a black hole without ever knowing it was there. It's only when you cross that event horizon, the point of no return, that things start to get strange. What happens next depends on how fast you're moving relative to the black hole. If you're moving slowly, you'll be pulled in towards the singularity at a speed that depends on how close you get to the center of the black hole. The closer you get, the faster you'll move. As you approach the singularity, everything would appear to be moving away from you at incredible speeds. And the gravitational force would become unbearable, eventually tearing you apart. If you were moving really fast, though, you might be able to escape by moving in just the right direction. You could actually avoid being pulled in by the black hole entirely and come out the other side. That's because black holes are not just cosmic abysses, they're also cosmic portals. Some scientists believe that black holes are wormholes, a type of space-time grid that connects to distant points in the universe. If that's true, then by traveling through a black hole, you could emerge in a completely different part of the cosmos. In fact, some scientists think that our entire universe is just one giant wormhole. If you could find the right black hole, you could travel to other universes. Unfortunately, we haven't found any evidence of wormholes yet, but the search is ongoing. Here's what we know. Black holes are incredibly dense. Just 1 teaspoon of black hole material would weigh billions of pounds. They also have a strong gravitational pull, which can be felt even from very far away. In fact, it's the gravitational pull of supermassive black holes that powers some of the most luminous objects in the universe, quasars. But despite their immense gravity, black holes are not cosmic vacuum cleaners. They don't actively suck things in. Rather, they just sit there. It's up to the objects around them to get too close and get sucked in. Most of the matter that falls into a black hole doesn't come from the universe next door. It comes from the universe we live in. That's because black holes are everywhere. There are millions of them scattered throughout our universe, and they come in all shapes and sizes. Some are just a few miles wide, while others are hundreds of thousands of miles wide. Most of them are relatively small, but there are a few supermassive black holes that are truly gigantic. At the center of most galaxies, including our own Milky Way, there is a supermassive black hole. These black holes are not only incredibly dense and massive, but they also have a strong gravitational pull. That's why they are surrounded by a glowing disk of gas and dust known as an accretion disk. As the material in the accretion disk falls towards the black hole, it heats up to millions of degrees and emits tremendous amounts of radiation. This makes quasars some of the brightest objects in the universe. And although black holes may seem like terrifying cosmic monsters, they're actually essential for the formation of galaxies. Without the strong gravitational pull of a supermassive black hole at its center, a galaxy would collapse in on itself. So black holes are everywhere, and they come in all shapes and sizes. They're also incredibly dense and massive, and they have a strong gravitational pull. But despite their immense power, they're not cosmic vacuum cleaners. They don't actively suck things in. Rather, they just sit there waiting for something to get too close and fall in. It's a relief. It's not a cosmic vacuum cleaner, isn't it? Thanks for watching. Don't forget to subscribe for more videos like this. And we'll see you next time.